Assalamu alaikum. In today's lecture we are going to study about the types of the transmission line based on the voltage level at which they are transmitting the power, as well as based on the length of the line. So before this lecture we have already covered the electrical parameters of the conductor, which were resistance, conductance, capacitance and inductance. And we talked in detail about the conductance and why we neglect them. So in these transmission line models we will only be considering resistance, capacitance and inductance. Starting from the short transmission line, so any line which is transmitting power up to 50 miles, or in kilometer we can say 80 kilometer, at the voltage level of 69 kilovolt, it can be termed as short transmission line. And usually we do not use capacitance in the transmission line model because there is not much an error in the calculation if we are calculating the voltage at the end of the line. Why? Because the leakage current is very small. Is very small. We know that the formula of the capacitive reactance is 1 over 2 pi Fc, and this capacitance is in per unit length. What does it mean? It means that there is a multiplying factor of 1 kilometer or 1 meter with this capacitance. So there is a variable L here, which is actually the length of the line. So the denominator term will be smaller in case of short transmission line because the length is smaller in comparison to other medium and long transmission lines. So if the denominator term is decreased, the Xc value will increase, and if the capacitive reactance value is larger, then the leakage current is smaller. So because of the length of the line, which is smaller with respect to medium and long transmission line, the capacitance is smaller. The capacitance is smaller means the capacitive reactance of a line is smaller in comparison to the other transmission lines, and that will have a smaller leakage current passing through those capacitances, right? And usually the capacitance value is between 8 to 9.5 nanofarad per kilometer, and it can go up to 12 nanofarad per kilometer in case of bundled conductors. So that's why we usually neglect capacitance in case of short transmission lines, and we use lumped parameters. And what are lumped parameters? For example, now we have neglected the capacitance for the short transmission line. So if we have to model the short transmission line, there will be one resistance and one inductance in the line, and this is the sending end voltage. This will be your receiving end voltage. We will have some load here. This is the resistance of the line, and this is the inductance of the line. We have capacitance and inductance value in per kilometer length, right? So we can represent the inductance and resistance of the whole transmission line with only one resistor and one inductor. So this is known as lumped parameter. But in case of long transmission line, we will use distributed parameter, and distributed parameter means for each unit length we will have a separate capacitor as well as inductor as well as a resistor. So we will talk about that in the long transmission lines. But if we do not assume the capacitance in the short transmission line, there is not much error in the calculation because the leakage current is very small, and there will be no current loss or power loss due to the leakage current. Now moving on towards the medium transmission line, the line length is from 50 to 150 miles, and in kilometers it will be from 80 to 240 kilometer. and the voltage level can go up to 100 kilovolts. And similar to the short transmission line, in the medium transmission line we will also use the lumped parameters, but now we are not neglecting the capacitances. And there are three models that we usually use in the medium transmission line. The first one is the end condenser model. The second one is pi model, and the third one is T model. In end condenser model, we have resistance, inductance, and capacitance, and this is your load. We have voltage VR across load and capacitor. At the sending end we have VS voltage and resistance and inductance. All the parameters of the line are lumped parameters, right? But in the end condenser model we are placing the capacitor, the lumped capacitor, in parallel with the load at the receiving end. So this is the end condenser model of a medium transmission line. In case of pi model, we have this configuration. The voltage at the receiving end is VR. This is the setting end voltage. This is your impedance, which is equal to R plus JXL, and this is your admittance divided by 2 and admittance divided by 2, right? So the capacitance value that is represented in the admittance is actually divided into two parts and is placed on both sides of the line impedance. So this is known as pi model. Now in T model, we will divide impedance into two parts, and the admittance will be placed in the center of these two impedances. Receiving end voltage, sending end voltage. This is your impedance that is divided into two parts, and this is your admittance of the line. And the admittance by formula is G plus JB, where G is the conductance and B is the susceptance. Similarly, impedance is R plus JXL. This is inductive reactance and this is your resistance. So these are the three models that we usually use in the modeling of a medium transmission line. And lastly, in the long transmission line, the length is increased above the 150 miles mark, and the voltage is above 100 kilovolt value. So now in this case, the leakage current value will be bigger value in comparison to the medium and short transmission line. Why? Because the length of the line is increased above 150 miles. So whatever the smaller value we have through each capacitance value in the model, it will lump up to a very larger value that can give some error in the calculation that we are doing in the load flow analysis in order to get the voltages at the end of the transmission line. So we cannot use lumped parameters in case of long transmission line because the length is increased too much and the leakage current through all the distributed capacitance values cannot be neglected. So for that we have to use distributed parameters, so the leakage current through each capacitance can be taken into account. So these are the three different models of the transmission line.